Alright, what is going on everyone? I hope you all are having a fantastic day. Today I kind of wanted to talk a little bit about Alder just because we're coming up on the release of it, and the hype train is starting to get going for these processors that are honestly going to change a lot about how we think about processor design and also how we approach power efficiency on desktop. So without any further ado, let's dive into this. Alright, so the first thing I kind of wanted to get out of the way is how these chips work. So I'm not going to go super in-depth, obviously, but what makes them different from a traditional CPU is the fact that this is going to be a hybrid architecture. Now, what hybrid architecture means is, if you're familiar with Big Little, which is an ARM-specific thing, Big Little means you have big cores, which are like the powerful cores that have tons of transistors, tons of execution ports, and then you have the efficiency cores or the little cores, which are smaller, literally take up less die space, run at a lower frequency, and just overall use a less amount of power. Now, what's interesting about this is it kind of allows the engineers to get the best of both worlds in terms of single-threaded and multi-threaded performance. And by that I mean, what they're doing is they're essentially throwing these giant cores at the problem that are meant to kind of take the lead for single-threaded, and then they're throwing these smaller cores at the problem, which are supposed to be more efficient ways of scaling multi-core performance, which honestly makes sense because if you look at the die shots of Alder Lake that Intel has released, it looks like you can roughly fit 4 of these efficiency cores inside one of these power cores, which means for the same die space as one of these larger cores, you can fit 4 of these smaller ones into it. So it's a much more efficient way of scaling performance. And honestly, when you think about it, you're actually getting much more logic on the chip just because of these little cores. I'm interested to see what happens in the future because if we look at the new M1 Pro and M1 Max chips, what's kind of strange about them is that the original M1 relied heavily on Big Little. It had quite a bit of these little cores and quite a bit of these powerful cores. The M1 Pro and M1 Max changes this to now have more, like way more of these powerful cores than the efficiency cores. Kind of interesting to see what happens with that, but on Intel, I'm honestly kind of more interested to see what happens when they add more of these Gracemont cores. So the Gracemont cores, if you don't know, are the code name for the little cores. They're built on 10 nanometer, as are the Golden Cove cores. Golden Cove cores are supposed to have, I believe, 12 execution ports, which is up from Ice Lake's 10, and is also higher than Zen 3, which I believe has either 10 or 11. I want to say 11, though. That means that these big cores are going to have tons of power behind them, just because they've got tons more logic stuffed in them. But the small cores is what I'm more interested in, just because they supposedly have the same IPC as a Skylake thread. Now, the difference between a Skylake thread and a Skylake core seems to be the fact that they're comparing 4 of these individual cores, these individual Gracemont cores, to 4 Skylake threads, which is a 2-core, 4-threaded situation. Honestly, it's kind of confusing when they market it that way. However, I understand where they're coming from. They're trying to give us a comparison point that we can kind of understand, given that we were stuck with Skylake for like 5 generations. But what I honestly find more interesting is how this will compare to other chips where they only have big cores, so something like the 5950X, the 5800X, stuff like that. And also Intel's previous gen 11900 and 11700K, because I have an 11700K review coming, and I'm honestly interested to see how it will perform against that chip, because the 11700K is pretty darn powerful. So I don't know how much more CPU performance will improve things, but at the end of the day, I'm always down for some more CPU performance. But that's really all I had to say on the matter. I know this was a very short video. The only thing I really had to say on the matter was that this is a more efficient way of scaling multi-core performance, which is something that a lot of people, I guess, are missing. Or it's an aspect that has been missing from the conversation, and I kind of wanted to get it out there to let people know that, hey, this is a more efficient way of scaling multi-core performance as opposed to just Intel being greedy and wanting to give you less cores for more money.